The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to this webinar about additive manufacturing, a game changer for the high-pressure die casting industry. In this webinar, you will learn more about how additive manufacturing can add value in solving common problems for high-pressure die casting applications. My name is Ulf Eisen, and I am Marketing Manager for voestalpine High Performance Metals in North America, the moderator for this webinar. This webinar will be recorded, and please contact us after the event to watch it again and get a copy of the presentation. But first, a disclaimer that please note that this presentation is for informational purposes and unauthorized reproduction or sharing is not allowed. So with that, a few words about today's presenter, Sami Arsan. Sami brings over 25 years of industry experience with leading tooling and equipment supply organizations, roles in global sourcing, advanced disruptive manufacturing technologies, and component engineering. He was a founding member of the voestalpine Additive Manufacturing Centers in North America. Sami holds a degree in mechanical engineering, is a product management professional, a professional engineer in the province of Ontario, and certified in additive manufacturing by SME. Sami, it's a pleasure to have you here today. How are you?
I'm good, thank you all.
All right. I think this is a perfect day to talk about additive manufacturing. So let's get moving. Over to you.
Thank you all. Thank you for the introduction, and thank for everyone for joining this webinar. And I hope that you will find it rewarding at the end of this hour we're going to spend together, learning a little bit more about additive manufacturing and how it can impact the high-pressure die casting industry. So I will start my presentation by a quotation that usually I would like to start the presentation with. Personally, I am very passionate about technologies in general and disruptive technologies, and I find that additive manufacturing is just one of these disrupting manufacturing technologies. So this quotation have been taken from Additive Minds, and it says soon there will only be two kinds of players: manufacturers who disrupt the market and those whose business is disrupted. And the way I look at this quote is in the last maybe couple of decades, there is always competition on pricing, trying to get, a lower cost, and you're competing by pricing in the market. Things are changing a little bit lately, especially with you cannot cut the cost anymore. So the only way to compete in your whatever market it is by innovation and having a disruptive technology, having a product that will be able to differentiate yourself from your competitors. So I find that additive manufacturing is not going to solve all your problems, but definitely it has a play in competing in the market in high pressure die casting. And that's what we are going to unfold together, going through a few slides together. So for agenda for today, I'm going to provide you a tooling approach for our company, which is voestalpine, which is a big group of companies together under one name, voestalpine, one step ahead, followed by our additive manufacturing approach from voestalpine. And then I'm going to give you a couple of case studies and success stories just to prove that additive manufacturing has a big play in the high pressure die casting industry. Last but not least, how we differentiate ourselves in the market by having a one-stop shop approach to our customers, providing a solution and adding value to our customers. So I'd like to start with this slide, which is a tooling approach for voestalpine Group. So voestalpine is a world leader in tool steel production and services since decades. So tool steel is actually in our DNA. So this is something we have been doing for decades, and this is part of who we are and how we're differentiating ourselves in the market. So if you look here, how many brands under one umbrella, which is a voestalpine one step ahead. Look on the left-hand side, you have the Bowler, you have Uda Holm, which is coordinating this webinar today. We have multiple companies, even like Coating from Eifler Coating and other as well from Edro. So if you look at this group of companies, global leading brands with a long tradition in a special steel sector, multi-brand strategy. So each brand symbolizes a separate performance profile in the market and actually generates strong brand loyalty. So we are complementing each other by each of these groups. So these brands clearly differentiate us from our competitors, as we are able here to provide a solution. We are not restricted by one type of service or one type of product, but we have multiple products. And the whole idea here is just to provide a solution to our customer, a value added. So optimizing and developing its brands creates value to our customer. So this is a very high level introduction to our group. And if you look at the value added service to our customers, besides the production mills and that I presented, we have warehousing in multiple locations, having material ready to our customer. We provide heat treatment, saw cutting as needed, machining as required, like 6-side machining or additional machining if required, coating, the new addition from iFleur, and last but not least, we added our additive manufacturing capabilities to complement the whole value added service to our customers. So when you look at the tooling approach, as I mentioned, we discovered that additive manufacturing is the missing link to a full solution provider. And that's why we embarked on this journey of additive manufacturing with our expertise in powder development and powder production and all the engineering support that we have and the post-processing. So AM was a key to be added to our portfolio. So switch gears now to focus on additive manufacturing, which is the main focus of this webinar. So I would like to start with a video, just a couple of minutes. This is from our group for voestalpine, and it shows you a focus on one specific technology, which is a powder bed fusion, which is mainly all the application I'm going to present in the case studies have used this technology, because with additive manufacturing, there is multiple technologies like direct energy deposition, wire arc additive manufacturing, but powder bed fusion is very applicable for die casting because it can provide lots of internal features. So let's watch together this video and then we'll continue our discussion for the webinar.
You've heard of 3D printing, right? Nowadays, we can print lots of different things out of plastic, including toys, fancy sculptures, our own little mini-me. But what about 3D printing using steel, nickel-based alloy, and other metals? Believe it or not, that's possible too. Whether you need parts for an aerospace turbine, a racing car, a medical implant, or a tool, you can print them all using what those in the know call additive manufacturing. By covering the whole value chain from the powder to the finished product, we at voestalpine will be the leading metal powder supplier for additive manufacturing and customized 3D manufactured parts. Let's take a look at how it works. Objects created using additive manufacturing are built up in layers according to 3D model data. Instead of cutting material away, it is added layer by layer to form almost any shape you need. For this metal processing, we produce high-quality metal powder within our group at Buller and Uddeholm. This is typically done by vacuum induction melting and inert gas atomization. The powder can be made from metals such as steel, nickel-based alloy, and cobalt chrome. First of all, the melted metal alloys are refined and degassed. This refined melt is then poured into a gas nozzle, where it is disintegrated into metal powder by a high-pressure gas stream. The different powder fractions are then put through a sieve to separate them before they are sealed in containers. Then we can start creating. At voestalpine, we use the so-called laser beam melting process. The first step is to slice a 3D CAD model of the designed component into cross-sections. This data is transferred to the additive manufacturing system, where a laser melts each section in 20 to 100 micron layers of metal powder from the bottom up until the part or prototype with full density is built. Additive manufacturing opens the door to a world of new possibilities in the production of tools and parts. Thanks to this state-of-the-art technique, we can now create custom-made parts with complex structures. we can make lightweight designs as well as improve conformal cooling by optimizing formerly inaccessible areas. And the economic advantages are numerous. Faster production, shorter development cycles, lower transport and storage costs, reduced raw material consumption, and the list goes on. Inspirational, isn't it? For more information, please contact us or visit our website at voestalpina.com/additive manufacturing.
voestalpina, one step ahead.
So hopefully the last couple of minutes was able to get everybody grounded about the technology and how it works. So this slide that you see, the message of the slide that you can see in front of you, several years ago when you start talking about additive manufacturing, people were concerned about the density that you can get out of building the part by powder. So it was around 95%, but over the years, with technical progress in laser technology, optics, software, and efforts in R&D, today you can get the density to 99.95, and if you need additional for any applications that would require maybe fatigue strength, you can just go for hipping as well, and you get it to 99.99. So this is to increase the confidence in the material integrity you get for AM is the same identical like the road steel. And this slide actually confirmed the same message. So this was from a voestalpine powder. If you look on this table on the right-hand side, if you buy road steel for the DIN 1.2709, and its hardness is up to 52 Rockwell, the tensile is 2000, the yield is 1930, and the elongation is 8. So if you build it by additive manufacturing, that's what we did internally, as printed, you can get it to a certain hardness and certain mechanical properties, and going through the heat treatment cycle recommended for this powder, you can get it to 55 Rockwell, almost identical to the road steel. And below two pictures from the microscopy, it shows how the density is observed. It is very high density for the AM on the left-hand side compared to the road steel. So these two slides just to confirm there is no risk of building by AM, by additive manufacturing, the inserts for high-pressure die casting. So the slide that you can see right now, the main message here is don't try to use additive manufacturing for parts which are dedicated to other manufacturing technologies. So additive manufacturing is only economical if you can add value to the part. And adding value could be different aspects that we're going to add value to this product. So the whole idea, you have to design the part to be designed for additive manufacturing, and then you can get all the benefits that AM can provide you in your industry. I'm going to switch right now to some case studies and success stories. So if you look to the high pressure die casting, what are the common failures? Common failures are like soldering. It's when aluminum or molten metal sticks to a die. This is one of the common problems. Another problem is heat checking, which is a combination of thermal cyclic stress, tensile stress, and plastic stress. Another failure is shrinkage porosity, which occurs during solidification and hot spots in the porosity zone. And another common failure is the mold erosion, which is a hot mechanical wear mainly due to the velocity of the melt. So these are common failures that's happening with the traditional mold being built. So how to improve the tool performance in high pressure die casting? There is multiple aspects that you can work on to improve the performance. One of them is the aluminum, requirement of the aluminum component. Another one is the casting machine itself, including the casting pressure, the filling factor, and casting weight. Another one is the spraying technology. It's micro spraying or the classical. Also the temperature, the core temperature, the surface temperature before spraying or after spraying, the plant cycle time, the contact time, casting simulation, and casting speed. Last but not least, the cooling system, the cooling media you're using, the cooling cycle, distance of the cooling to the surface itself. So if you look at the bottom three, these are the three categories that additive manufacturing provides a value or a solution in improving the performance of the high pressure die casting, controlling the temperature, the plant cycle time, and the cooling system as well. So for optimizations, high pressure die casting, how to optimize by additive manufacturing, it adds value by reduction of the scrap rate, which is commonly and very costly for the die casters. Part quality improvement, this is the value added by using additive manufacturing. The downtime reduction and the lifetime improvement, maintenance optimization, and last but not least, cycle time reduction. And if you look at the categories of groups of parts that could be improved by additive manufacturing, heat attack sliders, sub-inserts, and the distributor or ring as well. So this is some of the benefits that you can reap by applying additive manufacturing correctly and redesigning the inserts for additive manufacturing. Don't try to take the conventional design and build it by AM. The most benefit is going to be having a design engineer and a simulation engineer working hand in hand of redesigning the insert to minimize the scrap rate, increase the part quality, reduce the downtime, improve the lifetime, and optimizing the maintenance and reduction of cycle time. I'll show you a couple of case studies from our group that we have been working on. So for the ones that you have in front of us right now, the distributor, we use the powder from voestalpine, and the reason of applying additive manufacturing, the target was the cycle time reduction and lifetime improvement. And as you can see here, how complex is the internal cooling channels inside. So the time saving after 120,000 shots of this specific application, we were able to get a cycle time reduction of 2.5 seconds and lifetime over 200%. So in this case, the original cycle time was 53 seconds. We're able to drop it to 50.5 seconds. So 2.5 seconds per shot. That was the savings that we're able to realize on this distributor here. And from our group, we provided the powder, we did the design, simulation, the building, and the heat treatment as well. So this is just one of the success stories that we had in high pressure die casting. Another distributor as well, this was, the diameter was around 250 millimeter or a little bit less. The reason for using AM was a cycle time reduction and lifetime improvements. We were able to lower the cycle time by 3 seconds. This is compared to conventional cool distributor. And if you look on the right hand side here on the picture, just you see how complex is the shape of the cooling channel. You're able to get it closer to the surface with engineered in and out flow of the cooling. And the lifetime was improved by 150%. So this is here, literally, you're talking about huge improvement. It's not just evolution, but this is revolutionary in just having main improvement on your performance of the high pressure die casting application. Another example is a slider. This was for a car manufacturer, and its application here was a clutch housing. This was the insert. I would like to highlight here, if you look on the right hand side, the arrow, which says hybrid line. Within voestalpine, we are applying what we call hybrid build. The reason of hybrid build is two things. One, to minimize the need for the additive manufacturing, to add additive manufacturing where it's really needed, where it's going to add value, and at the same time to lower the manufacturing cost. So in this case, if you look at the bottom portion below this hybrid line, which is on the top here on this slide, you will find this is traditional bar have been drilled to have the inlet and outlet for the cooling, but the most complex portion for this fire and cooling channel have been built by additive manufacturing. So this is the message of the hybrid. So in this case, this was for a major car manufacturer. And the reason to use AM here, what we usually need to identify before working on a project, what is the value? Why do you want to apply additive manufacturing? So this was a reduction of scrap rate with a target and lifetime as well. So what we were able to get on the performance, we compared to conventional cooled slider, 600% improvement. So in this case, from 8,000 parts that you were able to get from conventional design, we are able to get 50,000 parts. That's unbelievable improvement that you can get by additive manufacturing, from 8,000 parts to 50,000 parts. It's unbelievable achievement that you can get by redesigning the part inserts by additive manufacturing. Another example is this slider as well. The application here is a gearbox sub-insert. And if you look, the challenge here was there was a hot spot on the traditional insert over 350 degrees C, causing some soldering problems. So in this application, we took like a complete approach to try to provide a solution to our customer, from the powder, design, simulation, additive manufacturing, building the insert, heat treatment, including as well the PVD coating that we have been able to apply. So compared to the conventional cooled slider, the scrap rate was reduced by 10%. Originally, the scrap rate was 16%, which is extremely costly. After additive manufacturing and solving the soldering problem by having the right design and the right cooling, we were able to get it to 6% scrap rate from 16%. So 10% scrap reduction, it can be translated to a lot in a dollar value for our customer. Another example here is a sub-insert, and this was a very critical insert for industrial washing machine. This was a pump housing sub-insert, and we used, you can see how complex is the design here. You're able literally to get the cooling where it's needed. And the main objective here is to reason for you lifetime and reduction of scrap rate. So compared to conventional cooled sub-insert, 350% improvement. So conventionally, they were able to get 7,000 parts. By applying additive manufacturing and the right design and getting the cooling where it's needed to be done with no restriction. Almost there is some guideline for the design, but you can say if you can design it, you can print it. So to get the cooling where it's needed, from 7,000 parts, you were able by AM to get it to 25,000 parts. That's really improvement in the lifetime of the insert. Another example, as you can see here, this was for a major OEM in car manufacturer, and extremely high temperature reduction. If you look at the soldering problem again here on the tip, it was over 370 degrees Celsius at the tip conventionally. This was for differential housing. So applying additive manufacturing, the scrap rate reduction from 20% to 6%. That is a huge, huge improvement into scrap rate reduction. And we applied as well the hybrid build approach that I explained before to minimize the cost for the customers, so they increase their profitability as well. And this 370 degrees Celsius soldering problem, by additive manufacturing design, we're able to lower the temperature to 280 degrees Celsius and with no soldering at all problem. So this is a huge, huge improvement. And this is just to get you that this is not just a prototyping technology, but now it's could be in a serial production. And it's working and has been proven with multiple customers to us. So this was just to highlight to you a couple of success stories and to increase your confidence that inserts are being running already in actual production environment with a huge success, huge acceptance for additive manufacturing in high pressure die casting. I will switch gear right now about voestalpine and what we can offer to our customer and what is our approach for additive manufacturing, adding value to our customer. The snapshots that you see here on this slide, we have multiple mills where we can produce the powder used in additive manufacturing. We have capabilities of approximately 240 metric ton every year for multiple grades, for multiple mills that we produce powder like Udahome. If you look at the powder production, there is multiple technologies that could be used for production, for atomizing the powder. The most common three is water atomization, gas atomization, plasma atomization. And as you can see on the left-hand side, the price goes up. From water is the cheapest, the plasma is the most expensive, and the powder quality as well goes up as you go from water, gas, and plasma. What we are using for additive manufacturing for the time being and for high pressure die casting is the gas atomization process, which is very convenient and optimized for this type of application. Plasma, it has its own niche, like for aerospace and for specific grades like titanium as well. But gas atomization is the most common production method for powder that's commonly accepted and used in this industry. If you look to the powder, for anybody would look at two batches of powder, they look the same. However, when you go deeper, it's completely different. And there is lots of aspects that affect the powder quality: the morphology, the shape, the inner and outer structure, particle size distribution, the humidity in the powder, oxygen content, chemistry, and flowability. That's why we put a very much focus on the quality of the powder we are producing and we are delivering to our customer, or we are using within our additive manufacturing centers internally. So if you can look at this, is multiple testing that has to be done at the mill. Like you have the cam sizer, as you can see here for on the top right, for the particle size distribution and checking the flowability, and everything is being done according to the standards. This is the sieving technology that we are using. So as you can see here, there is two-step sieving units. And for the powder sizes, for the powder bed fusion technology, the videos that we watched together at the beginning, it uses particle size distribution between 15 and to 45 micron. For different technologies, like direct metal deposition, you can use 45 to 90 or 45 to 150, depend on the technology. And we produce multiple particle size distribution serving multiple technologies. These are a snapshot of our atomization rigs at different mills that we have, and we are doing all the sieving under argon as well. So this is a snapshot of a grade, and the highlight of this slide, this was differentiation from our end in the market, that we produce powder for a specific application. So the one that you have in front of you here, this is Corax. It's a trademark for Udahol group, and it has been produced for a plastic injection molding application because of the high strength and the high corrosion resistance and the high polishability. And if you look on this slide, on the top row here for the yield and for the tensile, conventional compared to additive manufacturing, it's identical. And if you look on the right hand side on the polishability, it's even maybe better than the wrought steel because of the particle size distribution. So this is the message that I'm trying to send on this slide. This was a special powder being developed for a specific market with a huge success, providing value to our customers. And that's what we are doing in multiple industries as well, producing specific powder for a specific application. And to give you an example, this is another grade that we are using for high pressure die casting. So if you compare it to H11 or H13, there have been a project with OGI lab in Austria, with voestalpine, have been doing multiple testing. And in this case, there was over 800 specimen testing. As you can see here, it's being inserted in molten aluminum and then being cooled back and forth, back and forth, back and forth. And in summary, if you look here about grades that have been produced, adding value, it's better performance on the heat checking resistance compared to the traditional H11 and H13. And this was done by additive manufacturing. So we are literally trying to have a breakthrough technologies and specific powders that add value to our customers. And if you look at the right-hand side, going through the same thermal cyclic, how is the cracking? It's just being completely improved. And as you know, the heat checking resistance, it's the resistance to the combination of thermal cyclic stress, tensile stress, and plastic stress as well. So if this was the standard performance, the red line, it went far beyond, which is much better. So the message that regarding the powder, we have the standard material, voestalpine standard material, which has its niche application, and you have been doing it for quite some time, very successful, well accepted in the market, providing a value for our customers, and like for not bearing mechanical load, low velocity region, room for conformal cooling, or low tool temp at end of dwell as well. And at the same time, we have a premium material solving specific problems that you are not being able to get it with traditional material. So for example, a significant mechanical load or a thin weight savers that there is no room to add conformal cooling to it, or high velocity region. And what falls in between, we have a very strong engineering that need to determine what is the right material to be used by going through a simulation and identifying what is the potential, what is the value. And we need information from our customer on the casting process and the insert geometry to decide. But what I'm trying to send a message here, we can get it all. We can get it all. Whatever the type of powder needed, we can provide, and the design and the value to our customer. So this is the message here. You should get the cooling where you need it, not where you can drill it, not restricted by the design or where you can drill it and plug it. As an example, on the left-hand side insert here, you cannot just keep drilling because of this notch. However, with conformal cooling, you can go around it and you get it to the tip. So this is the message of AM, that you can get the cooling where it's needed. So this is the hybrid approach that I explained before in a couple of the case studies. And as I mentioned, the motivation of using it here is reduction of ZM volume to the functional areas that really require, and reduction of the manufacturing cost as well, which is benefit to our customer, trying to minimize the cost per insert. Switch gears right now to give you a snapshot about our additive manufacturing global network and footprint. We have 2 locations where we produce the powder, in Uddeholm in Sweden and Boller in Austria. We have multiple additive manufacturing centers. The first one was in Düsseldorf in Germany. Now we have 2 locations in China, in Shanghai and Dongguan. We have 1 in Taiwan, 1 in Singapore, and in North America, we have 1 in Toronto, Canada, and the other 1 in Houston, the USA. All these facilities are ISO certified, and the location in Toronto, Canada is AS 9100, which is mainly for aerospace. So we are qualified to deliver inserts for aerospace, which we are currently doing. The additive manufacturing technologies within our group, it's split into 3 major categories, and we are keep adding every now and then the new technologies. We have the powder bed fusions that we explained on the video, and a couple of the case studies has been built using this technology. And then we have the direct metal deposition, which is using metal powder, and we have WAM, which is wire arc additive manufacturing within our group. Having multiple technologies, we are able to provide a solution, not restricted to one type of technology. These are snapshots of the machines that we are having within our group, between the laser beam melting and direct metal deposition, and multiple materials that we are producing within our group. So switch gear a little bit about the quality of the printed part. It's a combination of multiple things. It starts by the design. You have to design the part for additive manufacturing to get the best benefit out of it. And then you look at what type of technology for printing, what is the printing parameter, printing strategy, machine concept, and then what is the post-treatment, what type of heat treatment, and what type of post-processing is required. All this affects the quality of the part you are building by additive manufacturing. And last but not least, definitely the material you are using, the powder and the quality of the powder. So for voestalpine, we are literally providing a solution along the whole value chain for powders and parts. So we have a location where we do the alloy development, and as I showed you before, we are developing alloys and producing as well. So we develop and we have a production capabilities at our mills. And then we go through the design and simulation, 3D building the part, heat treatment, and ready-to-use part at the end through our voiced Alpine additive manufacturing centers. So the 3 pillars of success, first of all, we build on the customer intimacy for sure. This is our foundation. And then we have optimized powder. As I showed you, have optimized powder for die casting or for injection molding or whatever type of industry we are serving. Optimize design and simulation, and then optimize printing and post-processing with the target to provide a tailor-made solution to our customer. So this is where we are building our success to provide value to our customers. So we literally offer end-to-end additive manufacturing services. So we do the design, simulation, manufacturing of the parts. We invest in the latest technologies of AM, and we provide to our customer multiple full portfolio of services from metal powder. We can provide design and engineering consultation, prototyping and production, or complete additive manufacturing solution. As you can see here, we have multiple design capabilities for tooling, like plastic injection molding, die casting, hot forging. As well, we can serve multiple industries in terms of oil and gas, aerospace, and general components, and we leverage the learning from each industry to focus on adding additional value in the design for other industries as well. We have a complete suite of simulation and modeling capabilities, from structural and thermal finite element analysis, including the standard structure simulation and the fatigue or tool component life. We have flow and thermal computerized fluid dynamics. We do the basic computerized fluid dynamics and comprehensive as well as needed. And we have end user process in high pressure die casting. We have MagmaSoft, which is our engineers are working very closely, design and simulation, multiple iteration, to understand and to quantify the benefits on the aluminum part itself. And the same in the plastic injection molding. For example, in the plastic part, how you can improve the warpage or the quality or improve cycle time. So we have this simulation software which we can work with our customers to show them the benefits even before building the part. And additive manufacturing specific simulation software to anticipate if there is any distortion, to optimize the support structure, and to develop, for example, a lattice or topology optimization for a lighter weight and saving on the building time as well. For material science and testing, this slide just would like to show you very high level. This is for a specific powder we have been running for serial production, and over the number of builds, it's consistent. So there is traceability and stability of properties during serial production. So it's not all over the place. And this is one of our unique selling proposition. The quality of the product that we are delivering, it's consistent over the number of builds, number of years we have been producing serial production. We do the incoming powder characterization at the Additive Manufacturing Center for the chemical composition and powder size distribution. We as well do the powder morphology and the powder flow measurements as well. And whenever we have a validation of a new powder or material at the Additive Manufacturing Center, we do the basic properties of different conditions as printed, heat treated, and if HIP is required as well. So we do the density coupons, tensile bars, Sharpie bars, and large blocks as well. And we do all the testing according to the standards. This is a snapshot of how we build the sample coupons on multiple locations on the platform and multiple orientation as well, to make sure we have a consistency of the parts being built. And we do the optical microscope and SEM machine as required for scanning the electron microscope. And we do the hardness testing and tensile testing as well in-house to make sure with every build we are building, we can make a testing to validate that the mechanical properties has been met before shipping any part externally. And this is a snapshot of one of our additive manufacturing center with the equipment that we are currently having. And we have the latest machine with the quad laser for high productivity and to lower the cost per part. Here is, as you can see, the 4 lasers are working together on 4 different parts. And we do the post-processing, powder extraction, shot peening, and support removal as needed. And this is a snapshot of what we have, what we call 3D scanning or reverse engineering. Every part that's coming out of the printer, we inspect it to make sure it meets the specification and according to the tolerance it's supposed to come out of the machine. And then when required, we do the conformal cooling test rate just to ensure cooling channels are free of powder and to verify the flow data against the simulation results as well. This we have a CMM coordinate measuring machine. In case we are finishing the complete machining, the customer can do the finished machining or we can do the finished machining. If we do it, we have to provide a CMM report that the final dimension have been met. And through the value-added service, we have a mill turn machine to complete the finished machining. And within our supply chain, we have multiple equipment through our suppliers that we can able to provide the required finishing operation, whether it's turning, surface grinding, sink or wire EDM, gun drilling, polishing, or cylindrical grinding as well. This is a snapshot of our heat treatment facility under the same roof, providing a wide variety of heat treatment and custom heat treatment cycle to make sure we are able to provide the customer. It's not that's what we have as a standard, but we can customize it to increase the benefits of the additive manufacturing built components. Within our group, we have the Eifler Voestalpine group that I introduced at the beginning, mainly designed to improve the performance and tool life, and all this under one roof. So we take full responsibility of the whole one-stop shop. With our quality systems, as I mentioned before, we have the AS9100 and ISO 9001. This is to ensure high quality standard of delivered components to our customers. And our quality system is just categorized into 4 categories: the order processing, vendor management, process control, and quality inspection of receiving powder in process and final before delivering to our customer. So it's very rigid quality systems that we are having within our group. This message I want to highlight, there is some challenges by additive manufacturing process. So you can hear about there is porosity or cracking or oxidation, residual stresses, or rough surface finish or dimensional deviation, some of the challenges. So if you look at the value chain from the powder, parameter development, design, simulation, building the part, post-processing, heat treatment, and final machine, if you get a cracking in the part at the end after delivering it, where is it coming from? If you don't know, it could be from the powder, it could be from bad design, or it could be not optimized building parameters. There is something went wrong during the build, not controlling the oxygen content as an example. Post-processing, maybe the heat treatment was wrong. So it's very hard to trace it back. However, with Voestalpine Group, we are combining a thorough understanding of manufacturing challenge with a forward thinking to embrace innovation. And we can track back what went wrong because we take full accountability of every instance that we are delivering. So this makes it more easier for our customers that they are going to be able to guarantee that we take full responsibility of the delivered insert. So this slide summarizes exactly what I've been talking about: one-stop shop from the powder method development from our mills, process parameters, application design, building the parts, post-processing, heat treatment, final machining, CMM, and polishing and coating. So the message here on this slide, this is an example of a jet array that we are using internally within our group, have been designed and built complete within our additive manufacturing center. So the main message here, we need to understand what is the AM needs, then we can formulate a complete solution. Whatever the solution is, solution could be maybe a special powder, solution could be a special design or a special simulation to make sure we can change the design back and forth for iteration, or it could be a coating process that we can just add a coating is going to solve a problem. And by one-stop shop, we can add value to our customers. So by this slide, I would hand it back to Ulf to see if there is any questions coming from any of the attendees today, and I would be gladly to answer any questions regarding this webinar. Thank you, everyone.
Thank you very much, Simon. Very interesting. For all attendees, if you have to leave now, just know that we have recorded this webinar and we will make it available on demand after if you contact us. Please sign up to our other webinars also about die casting solutions, materials, and coatings. And you will find that on the event page, www.uddaholm.com/us/events. So as Sami said, we will now take questions. We will keep this meeting open until all the questions have been answered. And we excuse in advance if there are questions we cannot answer because it's proprietary information about processes and patents. So let's see here what we have. I have a first one for you, Sami. Do you use the same powder as other AM suppliers? And do you have any special powder for high pressure die casting?
Very, very, very good question. I highlighted maybe quickly, I went quickly through it, that we have the same most common powder being used by the majority of the AM suppliers right now. However, we add to it a very custom powder for high pressure die casting, which we call it premium volatile beam powder, solving a specific problem or increase the performance of the standard powder compared to this new developed powder. So it's available from our mills. It has been running quite well. And some of the case studies that I presented, we use this unique powder from our mills combined with the additive manufacturing design, and the benefits was extremely, extremely good compared to the standard powder. So the answer is yes. And that's one of our differentiation in the market, producing a specific and tailored powder for a specific application, adding value to the customer.
All right, I have another one here. How large inserts can you build using AM?
Right now with the powder bed fusion, the capabilities goes to 16-inch by 16-inch, like 400 millimeter by 400 millimeter. This is the capabilities that we are currently able to print using quad laser.
All right, let's see here. If you want to highlight the key benefit for AM in high pressure die casting, what would it be?
Very interesting question. Very interesting question. First thing is redesign the insert. Design. I'll keep emphasizing the word design. Design for additive manufacturing. You should be able to design the internal of the insert to make sure you benefit from the additive manufacturing, which is for the time being, it could be conformal cooling, getting the cooling where needed. So it's mainly redesigning with getting the cooling where you need to be able to control the temperature, and this will be reflected in the cycle time and in the quality of the aluminum part as well.
All right, so let's see. Next one here. What makes you different from other AM suppliers?
I'm sure there's a lot of good suppliers out there. I think what I believe in additive manufacturing, it's complex process compared to traditional. Traditionally, you buy a bar or you buy a block and you have a design and you machine it, you check the tolerance, the part is good because you check the material, you have your mill certificate, you do ultrasonic testing on it, and that's it. And you print, you machine it and ready to go. With additive manufacturing, it's more complex, especially you are adding value in the design and simulation. So having everything under one roof with one responsible supplier with a one-stop shop. So this is a huge differentiation because first of all, once we understand from the customer what is the need, we can even develop a special alloy. You cannot have this discussion with the majority of the AM supplier. They have the standard powder and they are using it, which is not bad, but we can tailor the powder. We can make adjustment to the powder to make sure it delivers the best or to maximize the benefit. And then going through the whole value chain from the design and the simulation I showed you. I mean, we have a very specific simulation software for each market, building, and then having multiple locations as well. We have a global footprint, and say in North America, we have multiple locations. We can leverage multiple capacities as needed, as a backup capacities as well. And then going through the whole value chain of the post-processing heat treatment expertise within our group, so we can go back and forth to optimize the heat treatment, and the coating is required as well. So we differentiate ourselves by one-stop shop, providing a solution, adding value to our customer. So this is where we differentiate ourselves in the market. That was a good question.
All right. I actually don't see any other questions, so I think that's it. Thank you, Sami, and thank you all for attending this webinar. If you wish to reach Sami or an Uddeholm representative, please visit our website www.uddeholm.com or call us in the United States and Canada on 1-800-638-2520 or Mexico on 52-442-689-5900. There will be a short questionnaire when we close and also in the follow-up email, and there you can let us know if you want to be contacted to discuss our additive manufacturing solutions further. This, as I mentioned before, this webinar was recorded and we will make it available on demand as quickly as possible. So with that, I thank you, Sami, and I wish you all a good rest of the day. Thank you and goodbye.
Thank you all.